In the last video, I said that we usually make useful circuits from op-amps by applying feedback to them using external components. So since feedback is important to op-amps, and by the way it'll turn out to be important to many other electronic circuits as well, let's take a closer look at it. Feedback is when we take some of the output of a system and feed it back to the input. In the diagram on the screen, X in is the input signal and X out is the output one. The system gain or amplification is A. So if there was no feedback in the system, X out would be equal to X in times A. Note here that I've labelled the inputs and outputs X, because X could be any input, voltage or current or even mechanical movement or thermal input, for example. What we're about to discuss is universal. It applies to any sort of system. Now, beta in the diagram is how much of the output is fed back to the input. So if beta were equal to a tenth or 0.1 for example, then 1/10 of the output would be fed back to the input. For example, if the output were 10 volts and beta were a tenth, then XF would be 1 volt. In other words, XF is equal to beta times X out. If the feedback signal XF adds to the input X in, or another way of saying this is that if the feedback signal and input signal are in phase with each other, then we call this positive feedback. If, on the other hand, XF is subtracted from X in, or the feedback signal is out of phase with the input signal, then we call this negative feedback. Positive feedback increases the gain of a system, but makes it unstable and difficult to control. This can be useful to do if we want to deliberately create, for example, a waveform generator or oscillator. However, in amplifiers, positive feedback is usually a bad thing and to be avoided. Negative feedback decreases the gain of the whole system, but also makes it more stable. It also has a good effect on other properties of the circuit, reducing noise and increasing input impedance and reducing output impedance. Because of this, negative feedback is very useful in amplifiers. One problem that we will come across in circuits is that negative feedback can sometimes turn into positive feedback and cause a device to become unstable. It does this because of unwanted effects, particularly parasitic components. These can cause the feedback or the forward signal to become unexpectedly phase shifted. Unwanted feedback can also occur if a signal gets into the power supply lines, and this is why decoupling components are so important.